Hello and welcome back. Okay, I've got a lot of PCB work coming up to convert all of this over into more permanent PCBs. But before I go on, there's one last respin I'd like to do, which is the constant register here. Now, this has kind of been a source of contention for me for a while. Now, firstly, I changed my mind a little bit on what was going to go on here. So you see it's actually got a duplicate main bus display, which I want to get rid of. And rather than just desoldering the LEDs off it or the resistors off the back, I thought I'd take an opportunity to tweak the functionality. Now on the register boards it's the only one with a chip at right angles, but it's also got an interesting place in the functionality. So here we've got a constant load, so that's instructed a load of the constant register, and it's got this 2 value in it, which is now getting loaded into the A register. But the value down here is now completely redundant. And so I would like to see if I can add the functionality to this register to only display it while it's relevant. The main reason I'm doing that is because this is very much supposed to be a demonstration device, and the clearer I can make what the LEDs are showing, the better. So this is actually going to be the first fully functional board I replace. Okay, here's the schematic for the constant register. I've cloned a copy of it. Now this is the simplest register in the build, and we're going to make it simpler. This is the PCB. This is the main bus display that we wanted to get rid of. I think the copper fill didn't quite rebuild after an upgrade on this, so that's not quite how it is on the board at the moment. Right, well, let's get rid of the main bus display initially. Now, curiously enough, this register works like a cut down form of some of the other registers we've got out, in that a load signal will trigger a load into this 574 latch chip. We wire the output enable permanently to ground, so it's constantly outputting. So then these register output lines are both outputting to the LEDs, and they output to the inputs to this 541 line driver, which will push it back onto the bus when the assert to main happens. Now, the interesting thing here is that this could be done all with just one chip if we didn't need the LEDs. So here we're wiring directly between mem data and main bus, and then instead of output enable being always on, we use the assert to main line for that. So that one chip is the entire main functionality of the constant register. Right, so we don't need that anymore at all. So now this chip is actually implementing the constant register, and this 574 is taking a separate copy of the data just to output it to the LEDs. I quite like that, because if we wanted to, we could just cut this out and have a working constant register just without the LEDs. Right, so all of those main bus LEDs we didn't want any more have gone. That's going to be pretty easy to route. The last PCB I did, I used a stencil and the solder paste, and I'm probably going to do the same for this one. So there is something I would definitely like to do differently. Now, I've been doing all these resistors independently. I have ordered some of these resistor arrays. Looks like it's going to be easier if we turn these around, but apart from that, we're leaving them in the same location, which is all we need to keep things looking consistent. Okay, well, I like this because we've separated out the implementation of the register from the purely display section of it. But I wonder what else we can do. It's not necessary to do any more, but we do have an awful lot of space on that PCB. Can be interested to see how easy it is to solder these resistor arrays. They do look very small. This one would be easier to route if I turned the chip upside down and swapped the order of the lines. But I want to give it a try with hand routing it as it is, because having chips swapped around is a bit confusing on the soldering. If you were making a high-end computing device, you would need to worry about these tracks not being the same length and these tracks following the track underneath, and therefore adding a little bit of extra capacitance. But that happens when you've got way bigger numbers for clock rate than I'm ever going to get on this PCB. Okay, so let's have a think about what else we can do here. Now, in many regards, the constant register is actually an extension of the pipeline. It's kind of like a portion of the instruction register when an instruction contains 8 bits of immediate data. In fact, there was a time when I was sketching out the design for this processor when the constant register didn't exist as a standalone entity. It was part of the fetch unit, but it ended up on its own board. But all of its use, it stores a value for 2 pipeline steps. So it's loaded in one stage and then it's asserted to main in the next stage. And I've looked at a few videos and I've been discussing people's understanding of what's going on, and I've noticed that a few people get confused about the data in the constant register, because it very often is used to assign data into another register, it's kind of confusing that that data stays on the LEDs beyond the point when it has any purpose. So I'm wondering if I could build a circuit that only displays the LED output data from the constant register when it's relevant, which is between the load signal up to and including the assert to main signal, because the constant register has one load and then one assert to main. Let's see what we can do about that. Now these signals both go low when we're interested, so we'll use a set reset latch based off NAND gates. All right, we need another capacitor. Now, people have been complaining at me for going straight across a chip, which is really tempted to do here. That connection needs to go straight there. Okay, so that means that between the load and the assert to main, we will get a high out of here. But while the assert to main is on, we won't. So we want to merge those together. Actually, we're interested in the low going output. So that will be this one. So this is going to go high when we want to display the result on the LEDs. But the output enable down here that's going to control it is active low, so we need to invert that. And we can use a NAND gate here. Oh no, this is a NAND gate, so this is already an inverted output. So we've got a spare gate that we're not using. Okay, conveniently, I've got a set reset latch right next to me on this breadboard. Okay, so if we imagine this is the load and this is the assert. So we need to take the output of this latch, input to the next one. That will also come from the assert. And let's get this yellow LED and see what that looks like. Right, that's good. Load and it comes on because the value in the register is valid. Then while the assert is held low, it's still on, and then we remove it. But the output enable line is active low, so we do need the inverter. Okay, you can probably look back at the past videos in this circuit series to work out when I was doing this EDA. This output is the opposite of what we want, so we do need to invert it. Okay, I'm going to admit this just kind of hit a threshold of signals being inverted, so I actually quickly tested it on a piece of breadboard. To make a NAND gate into an inverter, we just put it into both inputs and then the output will be the inverted form. That's really nice because it uses every gate on this chip to generate our signal from the two inputs. So now the register valid signal controls the output to the register LEDs, and that circuit should be done. Do my best to ensure a much stronger power and ground lines than I've been doing before. I've definitely seen an improvement of the power stability on the more recent boards where I've been doing that. Oh, I have been improving multiple things at once, so it's not always easy to distinguish what's making the difference. Not so worried about ground being big traces because of the ground fill is going to take care of a lot of that. Okay, this has been a really painless board to route. Oh, the price for 5 has increased slightly. Not the end of the world. Well, I've got two parcels here. One of them's the PCBs, I hope, and the other one should be some parts, but I don't know which way round they are. A bit more obvious now. Let's have a look at the parts. Now, I ordered a whole bunch of these resistor arrays. These are like the 8-way ones that I use on the CPU build, but these are just 4-way. There's a couple of times when these would have been really handy. I needed to round up the price to get a different delivery tier. 74HCT00, that's the 4 NAND gates. I think those are op amps. So these are for some 4-way dip switches. Coupled with these should let me make some 4-value inputs on some of the builds. This board has one NAND chip. And these are the 4-way resistor arrays. Okay, now we're going to be driving red LEDs. Been using 1Ks on those. All passives are insanely cheap. So I just got 500 of each of these. I only need 2. A little bit of instant regret here because these things look tiny. Let's hope I can solder those okay. Yellow masking tape, PCBs and a stencil. Right, let's see what we can do. There's no cellophane on this one. Can't solder on this mat. That looks lined up to me. It's just a little bit of IPA. Okay, that looks pretty good so far. Okay, I appear to not have the markings on these LED locations, but this green bar points towards ground. I need to work out why I didn't get the symbols on this one. Well, I need the microscope to tell, but if I don't put these the same way around each, I will get in trouble. Well, I hope the solder flows well on that one. Okay, almost forgot these two resistors. That still just looks like magic to me. Something about that doesn't quite look right. Okay, so have I done everything successfully? This chip felt a little bit different, but it's secure. I see solder at all the points. I actually didn't get the soldering iron out, so a little bit of an extra delay there. Okay, now these were scary to put down, but they're really, really small compared to any of the other methods I've got for putting resistors on. Let's get the main build out and give it a try. Okay, they always start off shiny and then accumulate dust. Okay, give it a go. So here's a constant load, so here it will issue the load instruction to the constant register. And that hasn't worked. Okay, here's the curious thing. The 2 is there, so the register itself has actually worked correctly. But it only needed these 2 components to be operable. Everything else was about the visuals. I have been due a PCB not working. I've had far too much luck of late. Right, so assert to main should be low, and then load is high. Hang on, look at that. Low, high, low. So there's actually a signal there. I've got a horrible feeling I've put all these LEDs in the wrong way around. Now, if the rest of the circuit's working correctly, clock it once more, and I shouldn't have a signal here. Okay, so have I made the same mistake over here, or is the circuit not working? Yes, each and every one of these LEDs is the wrong way around. I am fantastically proud of that. Now what I've got here is a bit of Captain tape, which should be able to protect the rest of these components a little bit. I'd rather not mess those up. So the big question here is, can I place these on top and then reflow it? That would be a no. Okay, that felt way easier than I had any right to expect. See if we can get this back in. There's the load, and that's actually showing the value, and it showed the load. Now it shows the assert to main, and if we clock it again, that LED should go out. Hang on, I'm a complete fool. There's the load A, comma 2, but then followed behind it is a load D, comma 4. It's actually working correctly, but I didn't look at what instruction was behind the initial load. Ah, that's foolish. But that means my PCB works. So only when we've got a number in here we actually need does it show up. That's awesome. Putting the LEDs on back to front, mildly embarrassing, but yeah, then thinking I had a problem when I didn't on the circuit design, that's just silly. Okay. Well, I'm glad that worked anyway. Hope you found this interesting. I've got a big stack of PCB design which I've started on behind the scenes, but I'll hopefully be feeding out to you guys soon. Okay, thanks for watching. Goodbye.